want to talk about finding the area of a regular polygon. So first, let's just do a quick review of what is a regular polygon. If you think back, it's a polygon where all the sides are congruent and all the angles are congruent. And then under here, I just have kind of some pictures of some examples of things that hopefully will appear to look like regular polygons. And we're going to find out a way to find the area of all of those. Now I look at this and go, well, what could we do to find the area of those? I look at the first one, the triangle. Well, we already know how to find the area of a triangle. We can use our 1/2 base times height. You look at the square, we can do our base times height. We could do the 1/2 diagonal 1 times diagonal 2 because it's also a rhombus. So you have ways to find the areas of these two. But when you get into the hexagon or the pentagon or the octagon, how could we find the area of those things? Now what I like to do is break figures up into figures that I do know how to find the area. So what I'm going to do is I'm going to look at breaking them into triangles. And what I'm going to do is I'm going to go to the center and I'm going to draw in all the triangles that would be created by connecting the center to each vertex. So now I could go through and find the area of each one of those triangles. I could do that same thing in the pentagon. Connect all these, and then I have a bunch of triangles. Then come over here to the hexagon. Well, I'd have the same thing I could do on this one. And hopefully you're starting to see this pattern. And even if I go to the square, I could do that. And same thing with the triangle. Now I don't think I'd recommend it in the triangle and the square, but it is a method that we could use. Now like I said, once you do that, then it's just a matter of finding the area of each one of the triangles. Well, I'm going to go up here to the octagon. If I need to find the area of one of those triangles, I'm going to need to know the height of the triangle, which I just drew in there in the green, and I would need to know the length of the base, which would be right here. Not going to be any different if I go to the pentagon. I need to know the length of the height, and I would need to know the length of the base of one of those triangles. Same thing's going to happen in the hexagon. How long's the height? How long's the base? So now I'm going to come down here and I'm going to kind of put together a little formula to find the area of these. So what I need to do is, to find the area of my regular polygon, I want to find the area of each one of those triangles. I'm going to have to do 1/2 times the base. Well, the base of each one of these triangles is really nothing more than one of the side lengths. You got a side length here, so on. So I'm going to do 1/2, and I'm going to call it S for the side length, and then times the height of my triangles. Each one of those green ones would be H. So that would give me the area of one of those triangles. Now I'd have to multiply that by however many triangles are in each one of these things. So when I look at the hexagon, I notice there are 6 triangles. I look at the octagon, I notice there are 8 triangles. I look at the pentagon, there are 5 triangles. The square, there'd be 4 triangles, and in the triangle, there'd be 3 triangles. So the question is, how do I know how many triangles are inside? Well, 3 sides, 3 triangles. 4 sides, 4 triangles. 5 sides, 5 triangles. 6 sides, 6 triangles. 8 sides, 8 triangles. So that's telling me that, well, however many sides it has, it's going to have the same number of triangles if I create them the way I did. So then I'm going to multiply it by what I'm going to call n, thinking back to another formula that we used where n represented the number of sides. Now I'm going to manipulate this a little bit. We don't want to use that as our formula. You could, but I'm going to say let's not do that. So what I'm going to do is I'm going to take this, all of this, I'm going to clone it, bring it down. So there's my formula, but now what I'm going to do is I'm going to change the order because it doesn't matter what order I multiply in. I'm going to take the side length and the number of sides, and I'm going to put those together, multiply those. So when you look at this, these two things right here, if I take the number of sides and multiply it by the length of each side, that's really the perimeter. So now I have 1/2 times h, which we're going to find out on the next slide. I'm going to turn into a lowercase a equals area. And right here is the formula that we're going to use to find the area of a regular polygon. So keep that in mind. It's also going to show up on the next slide as well. Because here's my regular polygon. Now, I used the hexagon. You could have used any regular polygon you wanted. But there's some important pieces to it. One is going to be the center, which you can see. is right there. And then the other one is the apothem. That's a segment that's going to touch the center, if you want to think of it that way, and it's going to be perpendicular to the sides. That's that little a that I was talking about on the previous slide, called the apothem. And that's where it's going to come in handy into our area formula. So the area of a regular polygon is going to be 1/2 times the perimeter times the apothem. And if you want, you can do 1/2 times a times p. That's how I usually think of it, but it doesn't really matter which way you look at it. And that's going to conclude my lesson portion on areas of regular polygons.